This video is for those that missed the Zoom lecture today. Today is March the 30th, I think. And this is for those that missed the Zoom lecture this morning. This chapter is about right triangle trigonometry, or this first section is. So I need you to draw a right triangle over there in your notes in this packet. Label this angle theta. That's the Greek letter theta. Each side in the triangle is named based on theta. This side right here is named the adjacent to theta. That means it touches theta. This side right here is named the opposite of theta. And this side is the hypotenuse. The hypotenuse is always across from the 90. We can't call it adjacent even though it touches theta because it's always across from 90. There are 6 trig functions that you need to memorize. They are sine, cosine, tangent, cosecant, secant, and cotangent. I'm going to see if I can get a little closer so it's a little bigger for you. Get it focused there. Alright. I'm going to give you the formulas and I'd like you to write them down and then we'll explain what they mean. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. Cosecant is hypotenuse divided by opposite. Secant is hypotenuse divided by adjacent. And cotangent is adjacent divided by opposite. You need to memorize these 6 formulas. Okay. Let you get them copied down, and then I'll give you a memory trick to help you memorize them. Okay. If you haven't got them, I'll come back to it in just a second, but I want to give you the memory trick. The one Miss Harris gave you, if you took Algebra 1 with Miss Harris, was SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Okay, but if you're spelling challenged, that might pose a trouble with you. So this one, some old hippie, sine is opposite over hypotenuse, caught another hippie. Cosine is adjacent over hypotenuse, tripping. Now the non-Christian way I was taught this by Jonathan Cairns was tripping on acid, but because we go to Haywood Christian Academy, we're going to say tripping on apples. Tangent is opposite over adjacent. Some old hippie caught another hippie tripping on apples. Now the way that I learned it in the 9th grade when I had geometry, I had honors geometry, and my teacher taught us these. She taught us 3 Hawaiian words, made up Hawaiian words: sino, kosa, and tanawa. And that's the way I still remember them. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So whichever way you choose to memorize it, SOHCAHTOA, some old hippie caught another hippie tripping on apples, or sino, kosa, tanawa, or make up something of your own. Okay? These are the 3 basic ones. Now let's go back and let me show you my memory tricks for the other 3. Okay. If you like James Bond movies, and I do, then this is Claus. Santa Claus says ho ho ho. Cosecant, Claus, Santa Claus says ho. Secant is happy, so it laughs, ha. Secant laughs, ha. Cotangent sings reggae, ayo, ayo. So cotangent is A over O. And those are kind of silly, but they may help you remember them. Okay. Now in the lecture on Monday, we filled in 2 of these 3 blanks. I'm going to go ahead and fill them in for you so that you can fill yours in. If we have 2 sides, we use the Pythagorean Theorem to find the third side. If I have an acute angle and one side, I use sine, cosine, or tangent to find another side. And I'm going to explain these as we go. This one will come on Tuesday's video lecture. Okay, so let's work the ones that we worked in class so that I can know that you know what you're doing. Alright, so how do we do it? Cosecant of theta. The first thing I do is write down cosecant of theta, and I write the formula. Cosecant is hypotenuse over opposite. So I write cosecant is hypotenuse over opposite. I come over here to my triangle and I look. Right here's the opposite. I don't know it. Here's the hypotenuse. I know it. So let's fill the hypotenuse in. Okay. I've got to find the opposite. Look up here. If I have 2 sides, I use the Pythagorean Theorem to find the third side. I have 2 sides, but I need that one. So I'm going to use the Pythagorean Theorem. So the Pythagorean Theorem says a squared plus b squared equals c squared. A squared is going to be the 5. 5 squared is 25. The b is going to be the opposite. C is always the hypotenuse. So I have to square 5 on the square root of 5. So I square each piece. 5 squared is 25. The square root of 5 squared is 5. 25 times 5 is 125. So 25 plus b squared is 125. I move the 25 over and I get b squared is 100. So b must be 10. Now normally I would say b is plus or minus 10, but we're talking about a side, so it has to be 10. So cosecant is hypotenuse over opposite. So hypotenuse was 5 on the square root of 5, opposite was 10. Then I reduce the fraction. I can divide things that are outside, and that's going to give me the square root of 5 over 2, and that's my final answer. So cosecant of theta. The theta is the angle that goes in, and this ratio comes out. I asked the kids this morning Zooming to write this down. When you have a trig function, an angle goes in and a ratio of sides comes out. So that's what the trig function does. So what does cosecant do? It takes theta, which is this angle, and it puts it in, and what comes out is hypotenuse over opposite, which was 5 on the square root of 5 over 10, which reduced to the square root of 5 over 2. Okay? Let's do another one. Let's do number 3, tangent of theta. So I write down the formula. Tangent of theta, tan OA, is opposite over adjacent. So I look at here and I find my opposite. I don't know it, but I do know my adjacent. And 20 is my hypotenuse. But I need the opposite. If I have 2 sides, I use the Pythagorean Theorem to find the third side. So a squared plus b squared equals c squared. A squared is 16 squared plus b squared, I don't know, equals 20 squared, the hypotenuse. 256 is 16 squared. B squared is b squared. 20 squared is 400. I move the 256 over and I get b squared equals 144. So b has to equal 12. So my opposite is 12. So I come up here to my formula. Tangent of theta is opposite, which is 12, over adjacent, which is 16. I can't leave it that way. I've got to reduce, and I get 3 over 4. 4 goes into 12 3 times, 4 goes into 16 4 times, and there's my final answer. Okay? Now I would ask you to stop the video and work 6 on your own, and then come back and see if you got it right. Okay? Work 6 on your own, and then come back and see if you got it right. Okay, problem number 6. Tangent of theta equals opposite over adjacent. Right here, I look at theta. The opposite I don't know. The adjacent I know, it's 8. I've got to find the opposite, so I do the Pythagorean Theorem. 8 squared plus b squared equals 17 squared. 8 squared is 64. 17 squared is 289. I move the 64 over, and I get b squared equals 225. So b must be 15. b is the 15, which is the opposite. Tangent is opposite over adjacent, so 15 over 8. And then I'm done. Okay, I'm looking for something real quick. Okay, I found what I was looking for. Okay, so the answer to that one is 15 over 8. Alright, so these are the examples I did of that type. So now I'm going to stop this video so it won't get any longer and upload that, and then we'll do the second half, especially for Caleb.